So how do we avoid situations like the one we just saw, where the complexity of the code base made it difficult for us to see that a mistake was being made? Well, there are a couple properties that we want to make sure that when we write abstractions that our abstractions possess to ensure that we use those abstractions properly and we don't create security issues. So if we think of our application as relying on a layered set of abstractions, there are a number of principles that we want those abstractions to have. One of them is we want to have clarity with respect to security. We don't want to be able to look at our abstractions and not be able to obviously see how that abstraction is impacting security. We want to make security and our security decisions as much as possible a compile time decision. So if somebody's making a mistake with their security, we want to be able to catch that as a compile error. So we want to catch flaws as secure at compile time. So if somebody makes a security flaw in the code, we would like that to show up at compile time, not when the app is deployed and people are using it and it's causing data to be exposed. We also want to make sure that when other people use our code, that it's obvious how to properly use our code. So we want the proper usage to be obvious. And then finally, one other important property that we want is we want to be able to audit our code and ensure that we don't mix our data and our security model together in a way that exposes our security model to attacks from outside. So we don't want to make sure that we don't build abstractions where it's easy for people to go and inject data that changes our security decisions or changes our security state so that they can get us to do something insecure. So we want to separate and protect our security state. And what we'll see is that on Android, there's a lot of things that we can do that really make building abstractions and interfaces that have these properties much easier to do.